On this problem, we're being asked to graph this equation, and they ask us several questions about that graph. First, let's concentrate on graphing it. Remember that this -2 is going to give us an amplitude of 2, and it's also going to invert or reflect the normal cosine graph through the x-axis. Also, the minus pi over 4 being added to x will have a right shift of pi over 4 spaces. So if this is the graph of -2 sine x without the phase shift, notice the inverted sine function here, shifting it over pi over 4 spaces will give us the graph that we want. Now let's go about answering the questions. The first question is, how many local maxima are on this interval? Well, recall that the period of the sine function is 2 pi. Therefore, this distance is 2 pi. And therefore, the interval from 0 to 2 pi is here. And you'll notice there is one local maximum on that interval. So that's the answer to the first part of this question. The second question asks us to solve the equation f of x is less than or equal to 0 on the interval from 0 to 2 pi. Well, this portion of the graph is all the portion with the negative y coordinates, or 0 if you count the endpoints. And therefore, those are all the places where the function is less than or equal to 0. So what is that? What are all those x values included in that region? Well, remember, this is pi over 4, but this distance here is half of a cycle, or pi. So pi over 4 plus pi will give us the right endpoint of that interval, which works out to pi over 4. And the final conclusion for this question, therefore, is that the function is less than or equal to 0 whenever x is a number in this interval, which is represented by the red arrow in the problem, if you can see that. The third question here is to find the greatest value for which the function is decreasing on the interval from 0 to m. Well, since they specified a 0 here, let's project this graph backwards to 0, or a little bit past 0. And then notice that this graph is decreasing on the interval from 0 to wherever that thick blue interval ends. Now I could make something shorter than that, and it would still be true that the graph is decreasing from 0 to something shorter, but we want the greatest value of m. We want to extend that out as far as possible. So there's the largest interval, 0 to something, where the function is decreasing. Just a matter of finding out where that interval ends. Well, this distance here is a quarter of the wave, and hence has a length of pi over 2. So if I add 4 pi plus pi over 2, I'll get the right endpoint of that interval, which works out to 3 pi over 4. So you'll notice it's a true statement that the function is decreasing from 0 to 3 pi over 4, but also that's the greatest value of m, because if I made m any larger than 3 pi over 4, it would no longer be a true statement that f is decreasing on that entire interval. And there's that problem.